Hello, this is Eduardo Suarez. If you have watched any of my previous KAREL videos, you might have noticed that I've used routines several times. Routines are a very convenient way of writing your KAREL programs. They provide modularity by dividing the program into sections of code that are distinctive in functionality. Your program will be easier to read because it looks shorter and more structured, and also it will look more professional. In this video, we're going to look at routines, what they are, and how they can be used. Routines are very similar in structure to programs, but we need to make a first distinction. There are two types of routines. The functions routines are the ones that return a value, and the procedure routines, they do not return any value. We're going to start by creating a KAREL program, and I'm going to use a very simple example that is easy to relate. If we go to files, here I have my KAREL program. I call it calculator, and what this program is going to do is going to ask the user to enter two numbers, and it's going to give us the addition of the two numbers. So the first thing we're going to do on the declaration section of the program, we're going to declare two integer values, integer 1 and integer 2, and also the addition result is going to be an integer. And in the executed section of the program, the first thing I'm doing, I'm going to clear out the screen, and I'm going to force the TP user one screen. And then we're going to write some statements. We're going to write the select two integer numbers, and we're going to write enter the first number, and we're going to read the number, and then we're going to enter the second number. We're going to calculate the addition of both numbers, and we're going to show the result. So we're going to try this program. We're going to build it. Open the teach pendant. I'm going to select the program, and we're going to press shift and forward. And here we have the execution of the program. So first thing it did, it cleared the TP screen, and it forced the user one screen. And it wrote the statement, selected two integer numbers, and it's asking for the first number. So we're going to enter a number, and we're going to enter the second number, and it's going to produce the result. Selection, and we're going to select any other program, so this way anytime that build the program, we're not going to have any errors. So we're going to minimize this one, and now we're going to look at a way that we can create a routine. So we want to divide the executed section of the program into routines. This must be declared on the declaration section of the program, and you always need to declare a routine before you use it. The way we're going to declare a routine is with the statement routine followed by begin and end. So we're going to go to the declaration section of the program. We're going to write the statement routine. We're going to write the statement begin and the statement end. You're going to have a declaration section of the routine where you can declare all your constant and variables. There are some limitations to the type of variables that you can declare. You can look at the KAREL reference manual for more details. Then we're going to have the executed section of the routine with the statements begin and end. And inside the routine, we can call another routine, but we cannot declare another routines. And something interesting about the routines is that it can call itself. You can see an example of that in the KAREL reference manual. So what we're going to do, we're going to move this part of the executed section of the program. We're going to take it from here, and we're going to move it to the executed section of the program inside the routine. One more thing we're going to do, we're going to give it a name. We're going to call it clear screen, and you need to put the name after the statement routine, and also we need to put the name after the end statement. So in this case, you can see that this is going to be a procedure routine because it's not returning any value. And in current case, we don't have any variables. One more thing that we need to do. So this was just the declaration of the routine. You need to declare the routine at the beginning of the program, in the declaration section of the program, and before you call it. And also we need to just call it inside the program, and the way we're going to do that is with just the name. So you can see that calling a routine is exactly the same as writing another statement that is going to be just the name of the routine. If you look at the KAREL reference manual, they use two different names for calling a routine. They say either call routine or invoke a routine, and they use that in a distinctive way. So you can either use call the routine or you can use invoke the routine. So something that you need to know about the calling the routine is that the execution of the program is going to stop the moment that you call the routine, and the execution is going to be transferred to the routine until the routine's finish its execution, and then the control is going to be passed back to the place where the routine was called. In this case, it's going to go to the next statement in the executed section of the program. So we're going to save this program, we're going to build it, and we're going to run it. Select the calculator, and you can see that this is going to work exactly the same as the program that we had before, where everything was in the executed section of the program. So something I mentioned before is that the routine must be declared before it is called, and there is an exemption for that. When you have the routine declared in the same program where you're calling, you can change the order, and we're going to see an example of that. In this case, we can take all this one, we're going to copy, and we're going to just delete this part in here, and we're going to move it to the end. So after the executed section of the program, we're going to write the definition of the routine. And in this case, if we want to do that, we need to use the statement from, and we need to tell them where the routine is declared. So in this case, we're going to use a calculator. So this is the way that you can change the order of the routine, and this is valid only if you have the declaration of the routine in the same program. So we're going to now we're going to select another program, and we're gonna save it, and we're gonna build it, and we're gonna run it again. Seeing that the program works exactly the same. Now we're gonna do something different. We're gonna declare the routine in another program, and we're gonna call the routine from that program. I'm gonna create another KAREL program. I call it clear screen, and notice that I moved the routine to this program, and on the executed section of the program I don't have anything. So the only purpose of this program is just for declaring the routine. So we're gonna save it, we're gonna build it, and now what we need to do, calculator, we're gonna delete this one from here, and on the declaration section of the routine we're gonna use exactly the same statement. We're gonna call the routine clear screen, but this time we're gonna make reference from, and it's gonna be from the program clear screen. And you can notice that I'm calling the routine exactly the same way that we did that before. So we're gonna save it, we're gonna build it, and we're gonna run it. There's no difference. It works exactly the same. We can do one more thing. We're gonna go back to the clear screen program, and this time what we're gonna do, we're gonna call the routine from the executed section of the program. We're gonna save it, we're gonna build it, and now we're gonna go back to the calculator, and this time instead of calling the routine, we're gonna call the program that is gonna be the one that's gonna call the routine. So there are two different ways that we can call a KAREL program from another KAREL program. I'm going to show you one way, and it's using the instruction call program. So instead of this one, we're going to just put in here the instruction call program, and as a string, we need to indicate the program we're going to call it, and we have an additional here that's going to be the program index. And for that, what we need to do, we just need to declare the declaration section of the program. We need to add one more variable that's going to be program index. So this is program, and this one works for either calling a TP program or a KAREL program. We are not going to go that way, so we're going to reverse all these changes. And instead of that, what we're going to do, we are going to call the TP program clear screen with us this instruction, and in the routine we are going to call the KAREL program and with the instruction from KAREL program. So this way will be exactly the same as calling a routine. We're going to save it, we're going to build it, and we're going to run it. the calculator again, and you can see that the program works exactly the same. We're going to go back to the executed section of the calculator program, and this time we're going to add a function routine. So in the declaration section, we're going to add a new routine I call add numbers. And what this routine is going to do is going to add the two numbers and give us the result. This is a function routine and is going to need data from the calling program. So in the declaration section of the routine, we need to add the declaration of the data that we want to receive, and this is called parameters. This is going to be the parameter list. So one thing we're going to do, in parentheses, we're going to add the parameter list, and at the end we need to declare what type of data we're going to return from the routine. On the declaration section of the program, we're going to declare a new variable we're going to call a result integer. And on the executed section of the program, we're going to take the two parameters. We're going to do the addition, and we're going to assign the value to result. And then in order to return the value from the routine, we need to use instruction return, and in parentheses, we want to select the variable. Something I want to notice in here, that in procedure routine, you can also use a return statement. The difference is that because the procedure routine doesn't return any value, the statement is going to have any parentheses. You can use a return statement on a procedure routine. For example, when you want to have some control on the executed section of your routine. Let's say you have an if instruction that under one condition you want to finish the program, and you go to the return, and on another condition you want to continue with the execution of the program, and the program is going to finish when it finds the end statement. So now we need to call the function routine, and the way that we're going to call the function routine is different from the procedure routine. In this case, when we call a function routine, we need to do an assignment. So we're going to do the assignment of the return value from the routine to the variable at result. Then you need to pass the data, and in this case, the data is called arguments. So in the calling side, it's called arguments. On the receiving side, it's called parameters. And the argument list, it needs to match in number and in type to the parameter list. You're going to notice in here that when we call the arguments, we separate the arguments by comma, and on the parameter list, you're going to separate the parameters by commas only when you have the same type of variables. Let's say if we do something different, if we take this one from here, and we do something like this, we are defining two parameters separately. In this case, you use a semicolon instead of a comma. We're going to look at the how the execution of the program is going to work. So when we call the in, we're going to stop the execution of the main program at this point. We're going to transfer the control to the routine. The routine is going to finish this execution, and the control is going to be passed back to the program at the point that was called. So in this moment, we're going to do the assignment to the variable, and from here it's going to continue to the next statement. So we're going to save it, we're going to build it, and we have a problem. This time we change the declaration of the program. So what we're going to do, we want to delete this data. Ready to go. Select this, and you can see that the program still works the same way. We're going to go back to the calculator program, and this time we're going to look at how we are passing the data to the routine. There are two different ways we can pass the data to the routine. We can pass the data by reference, or we can pass the data by value. Normally, we're going to pass the data by reference, except if you're using constants or expressions. And to illustrate that, we're going to make a small change in the routine. We're going to take here, we're going to delete it, and we're going to change this with this routine. So we change from a function routine to a procedure routine, and this time I'm passing as a parameter the result, and we're going to assign the addition of the two parameters to the result. We're going to show the result inside the routine, and one more thing that I want to do, this one in here, and we're going to replace it with these instructions. So we're going to show the result inside the routine, and also we're going to show the result inside the program. And we're going to notice a difference. So the first things we're going to do, we're going to pass the values by reference, and that's the way we're going to call it on the argument list. So we're going to save it, we're going to build it, and we're going to run it. You're going to notice that in here, I have the add result, I put it to 0, and then we're going to get the result back from the routine. So now if we put the numbers, you're going to see that inside the routine we have the result is going to be 2, and on the main program is going to be 2. So what we're doing here, where we passed the data by reference, the data in the argument shares the same memory area that the data that we have on the parameters. So changing the parameters also is going to change the argument. Now we're going to make a change, and we're going to change this calling routine, and we're going to pass the data by value, and the way that you can do that is putting the argument inside the parentheses In this way, the parenthesis is going to work exactly the same as an expression. So with this little change, now we change from a reference to value. Say that again. We're going to go back in here. We're going to select another program. We're going to build it. Now that inside the routine, it took the two arguments, integer 1 and integer 2, and it gave a result that is going to be the addition of the two numbers. That's what we're showing in here. But because we pass the data by value, this is not reflected on the argument. So in the argument still we have the value 0 that we wrote originally. So this is going to be the main difference between passing the data by reference or by value. In reference, you're going to share the same memory space, and when you pass by value, it's just making a copy of the value in the argument and using that value in the inside the routine, and nothing else is going to be affected on the main program. In here is that all the data that we have inside the routine is going to be local to the routine. So the parameters and any variable that you define inside the routine, including labels, this is going to be local to the routine. The moment that you call the routine, they are going to be created, and the moment that you finish the routine, they are going to be destroyed. And one way to look at that, if we select the case, we can go back to the data, select KAREL variables, and you can see here the variables for calculator, and the only variable that we have is the one that belongs to the program, but it's nothing there that relates to the routine. So in terms of the routine, you're not going to have access to the local variables that we have in there. I want to show you the final version of the calculator program. We're going to have two variables, options and finish. That's going to be Boolean. Then we're going to call exactly the same clear screen routine that we have declared before. And we're going to declare a few more routines. That's going to be the addition of the numbers, the subtraction of the numbers, the multiplication, and the division. On the executed section of the program, we're going to have flag that is going to be initialized to false. That's going to indicate when we finish the program. And then we're going to have an infinite loop with a repeat until, and this is going to finish when we have the flag finished to true. Then we're going to have a label that's called start selection, and we're going to go from here to the label. We're going to call the routine clear screen. You can see also that I'm calling the clear routine screen inside any other routine. So I'm calling a routine inside a routine. And then we're going to write all the selections of the operation that we can do, either an addition, subtraction, multiplication, division, or exit. We're going to read the option and we're going to use the select instruction, and according to the option I'm going to be calling the routine. And if the option is 5 to exit, I'm going to change the flag finish to true, and I'm going to go to the label that's in selection, and from the end selection I can just finish the infinite loop. If we are doing the wrong selection, we're going to go back to the label start selection. And in the case, we're going to be waiting 5 seconds before we start the selection again. So we're going to build the program and we're going to run it. Here I have all my selections. We're going to start with an addition. So now we're calling the routine for the addition. We're going to enter a number, the second number, and we have the result. It's going to wait 5 seconds and it's going to go back to the selection. We can select the second option, the subtraction. We can select the first number, we're going to select the second number, and it's going to give us a result. We can use the third one, multiplication. And if we select the wrong option, let's say we select 6, that is not a valid entry, it's going to go back to the selection again. And now if we want to just exit the program, we just press 5 and the program is finished. To summarize, I've covered the basics of routines. We saw some of the benefits of using routines. They provide modularity to the program. You can structure your program in a way that when you're using the same piece of code several times, you just put it in the routine and just call it from there. We saw there's 2 types of routines, functions routines and procedure routines. We saw how to declare a routine, and we saw that the structure of the routine is very similar to the structure of a program. Also, we saw how to call a routine from the same program or from a different program. We saw how to pass arguments to the routine parameters, and we also saw the scope of the variables. We can pass the arguments by reference or by value. A routine cannot be declared in another routine. It can only be declared in the declaration section of the program, but we saw that a routine can call another routine and it also can call itself. There are a few more things that I haven't covered in this video. There are limitations to the type of variables that you can use inside a routine. You can declare variables and constants inside the routine, but you cannot declare type variables such as user-defined structure or user-defined variables. Also, I haven't talked about arrays and how to handle arrays inside the routine. As always, refer to the KAREL reference manual for more information and examples. And you can also look at my previous KAREL video for more examples on how to use routines.